About 13.8 billion years ago, the universe began with the event known as the Big Bang. In its earliest moments, the cosmos was unimaginably hot and dense, filled with an expanding sea of particles and radiation. For hundreds of thousands of years after this beginning, the universe was not a place of stars, galaxies, or planets. It was a glowing plasma where light constantly scattered off charged particles. Eventually, the universe cooled enough for electrons and protons to combine into neutral hydrogen atoms. At that moment, the universe became transparent, allowing light to travel freely for the first time. That ancient light still exists today as the faint radiation known as the cosmic microwave background. But even after the universe became transparent, something surprising remained missing. There were still no stars. For millions of years, the cosmos entered a period often called the Cosmic Dark Ages. The Cosmic Dark Ages. During this early era, the universe looked very different from what we see today. There were no galaxies lighting up the darkness, no glowing nebulae, and no clusters of stars. Space was filled mostly with hydrogen and helium gas, drifting quietly through an expanding universe. The sky would have appeared almost completely black. Small variations in density already existed in this early matter distribution. Some regions contained slightly more gas than others. These tiny differences were left over from fluctuations in the very early universe. Over time, gravity slowly amplified those differences. Regions that were slightly denser began attracting more matter. Gas clouds started gathering into larger and larger clumps. These growing concentrations of matter were the seeds of the first stars. The first cosmic clouds. Hundreds of millions of years after the Big Bang, enormous clouds of hydrogen began collapsing under gravity. These clouds were very different from modern star-forming regions. The early universe contained almost no heavy elements. Only hydrogen, helium, and tiny traces of lithium existed at that time. Because of this limited chemistry, the gas behaved differently from the gas clouds found in modern galaxies such as the Milky Way. Cooling processes were less efficient, which meant that the collapsing clouds tended to form extremely massive stars rather than smaller ones. These first stars were unlike most stars that exist today. They were enormous. The birth of the first stars. Eventually, the collapsing clouds reached temperatures and pressures high enough to ignite nuclear fusion. The first stars in the universe were born. Astronomers call these early objects population 3 stars. They were composed almost entirely of hydrogen and helium, the simplest elements created shortly after the Big Bang. Many of these stars may have been dozens or even hundreds of times more massive than the Sun. Because of their enormous mass, they burned extremely hot and bright. Their surface temperatures were far higher than those of most stars today, producing intense ultraviolet radiation. For the first time since the beginning of the universe, large regions of space were illuminated by starlight. The cosmic dark ages were ending. Lighting up the universe. As the first stars ignited, their radiation began transforming the universe around them. The intense ultraviolet light emitted by these massive stars started ionizing the surrounding hydrogen gas. Neutral atoms lost their electrons, turning the once dark intergalactic medium into glowing ionized plasma. This process is known as cosmic reionization. Over hundreds of millions of years, more and more stars formed across the universe. Their combined radiation gradually carved enormous bubbles of ionized gas in the surrounding darkness. Eventually, these bubbles expanded and merged, filling most of the universe with ionized hydrogen. The first generation of stars had fundamentally changed the state of the cosmos. The first explosions. The first stars lived very short lives. Because they were so massive, they burned through their nuclear fuel extremely quickly. Some may have survived only a few million years before reaching the ends of their lives. When they died, many of them exploded in enormous supernovae. These explosions were far more powerful than typical supernovae seen today. Some may have been parinstability supernovae, events so energetic that they completely destroyed the star without leaving behind a neutron star or black hole. For the first time in cosmic history, heavy elements were forged inside stellar cores and blasted into space. Carbon, oxygen, silicon, and iron began spreading through the universe. These elements would eventually become the building blocks of planets, oceans, and living organisms. The birth of galaxies. As the first stars formed and died, gravity continued shaping the universe on larger scales. Small clusters of stars gathered into larger systems. Gas clouds merged and collapsed repeatedly, gradually forming the earliest galaxies. These primitive galaxies were smaller and more chaotic than modern ones. Over billions of years, they would grow through mergers and continued star formation, eventually becoming the massive galaxies we observe today, including the Milky Way. But in those early hundreds of millions of years, the universe still looked very young. Galaxies were scattered islands of light, separated by enormous distances. Between them stretched vast oceans of darkness. A universe taking shape. If an observer could travel back to that era, the night sky would look unfamiliar. Instead of billions of mature galaxies, only small clusters of newly formed stars would appear scattered through the darkness. Many regions of space would remain unlit, still waiting for their first generation of stars to ignite. The universe would feel enormous, quiet, and young. But the transformation had already begun. Each new star added light to the cosmos. Each supernova enriched the surrounding gas with heavier elements. Each forming galaxy helped shape the large-scale structure of the universe. Over billions of years, these early beginnings would grow into the complex cosmic web we see today. All galaxies, stars, and planets trace their origins back to that moment when the first light switched on. The universe began in darkness. But once the first stars ignited after the Big Bang, the cosmos entered a new era, one where light, structure, and eventually life became possible.